In this exercise, we have the vector space R3 and we have two different bases, B1 and B2. And we have T, which is a linear operator on R3. In case you forgot what linear operator means, it just means that it's a linear transformation from R3 to itself, R3 to R3. Now we're given two things. We're given the change of base matrix from B1 to B2 is this, and we're given the representation matrix of T relative to basis B1. And we have to compute these two quantities. And let's take them one at a time. Okay, so here we are with the change of basis from B1 to B2. And you just have to remember the formula. We've done this in a previous exercise, that if you do the opposite from B2 to B1, all you have to do is take the inverse of this matrix. This will always be an invertible matrix, so you have to remember how to compute inverse matrices. Okay, just let me write that this is equal to this. Minus 1 means inverse. And the standard technique is to take this matrix, and alongside it we put the identity matrix with a separator, a kind of augmented matrix. And what we want to do is to do row operations until on the left side we get the identity, and what we have left on the right will be the inverse. So let's start. We can get these two to be 0 by adding this row to this and this. So yeah, adding this to this and this does give us zeros here, and this is what we get. Don't forget, we also have to do the right-hand part, of course. So I'm adding this to this and to this. That's like the ones here and so on. Let's see, what's next? We would like a 0 here, then it will be in echelon form. So take 3 times this row and subtract 4 times this row. Then you'll get here 12 minus 12, and that will be 0, or rather it's minus 12 plus 12, minus minus. And here we are, but we don't stop when we have a row echelon form. We want to keep going till we have the identity here.